Good morning, all.
Good morning, ma'am.
We are discussing about testing of digital circuits. Okay? And in that, we are going to discuss about, as I said earlier, we are going to discuss about various testing methods or testing techniques for this digital circuits. Now, as we have two types of circuits. One is the combinational logic circuit, and another one that is a sequential logic circuit. Combinational circuits that depend on the current input state one. Okay, that means whatever input that we are applying to the circuit, depending on that we will get out. But if we look for the sequential circuit, output of sequential circuit that is dependent on previous state output also. Okay, so that means it is dependent on the current input state and previous state output. Okay, and that is why it becomes little bit difficult to take sequential logic circuits. Okay, so we are going to discuss about both these circuits and then how we are going to test these circuits. Okay, so in that, in the yesterday's lecture we have started with one method, that is a stuck at fault. Okay, that means suppose there is any wire that is connected permanently to any of the logic level. That means it is either connected to zero logic level or it is connected to one logic level. Okay, if it is permanently connected, then it may result wrong output at the output of that circuit. And then how to test that we are looking for. And here in the last lecture we discussed about how we can test it for a simple AND gate. Okay, so 3-input AND gate, how we can do it, that we have discussed. Okay, so continuing with that. Till here we discussed in the last lecture that if we have a AND gate, that is a 3-input AND gate which has 3 inputs, that is A, B and C. Okay, and out of that, one input is connected permanently to the zero logic level. That means it is stuck at 0. Then in that case, what we can do, we can apply input, that is a 111, to all the input terminals. And actually, if the AND gate is in a good condition, then it should result in a high output. But if it is giving a 0 output, that means if it is a actually wrong output, in that case we can say that that gate is a faulty gate, and one of the terminal of that gate that is connected at 0 logic level. That means it is stuck at 0. Or if we give the input that is a 0, 1, 1. Okay, and if that line, that wire is stuck at 1, in that case actually if we are giving the input that is a 0, 1, 1, that means output should be 0. Okay, in a good condition. But if that line or that wire is connected to the high logic level, it may result in a 1 output. Okay, and that means we can, from that we can decide that that wire is connected or it is stuck at 1. Okay, so in that way we can do for the OR gate also. So here by having all the input combinations, by checking with the input, different input combinations, we can say for the result of that gate. Okay, so that, like that way we can do it for the different combinational circuit also. So that means depending on the input, okay, terminals, we can give the different input logic level. Okay, and then we can test for the output, and from that we can decide whether that circuit is in a good condition or in a faulty condition. Okay, so let us take one more example for this circuit. Okay, here what we have done, we have taken one circuit which is a 3-input combinational logic circuit, which is a combination of OR gate and AND gate. Okay, so here we have applied W1 input to the one of the input terminals of OR gate and W2 and W3 that are connected as an input to AND gate. Output of that AND gate is connected to the OR gate. Okay, and then we get the output, that is F. Okay, so there are three inputs as I said, W1, W2, W3. These are three inputs. F is the output of this circuit, and then there are 5 wires in this circuit. Okay, so here A, that is the one wire, then B, that is the another wire, C, that is the third wire, D is the fourth wire, and F, which is connecting output of this gate to the output terminal, that is output pin, that is the F is the fifth wire in this circuit. Okay, now we want to check whether there is any fault or stuck at model fault at this circuit or not. That means it may happen that here A could be connected to either to 0 logic level or 1 logic level. Then for the B also it could be connected to 0 logic level or 1. Similarly for C, D and F, okay, it may be permanently connected to 0 logic level or high logic level in a faulty condition. So now we want to check for these conditions. Okay, so whether it is a faulty or not. So what is done? We apply a test vector to this circuit. Okay, so depending on the input terminals. Now here there are 3 input terminals. So we are applying a 3-bit input to this circuit. That is a, suppose first we apply a input vector, that is 0, 0, 0. Okay. Now if we have applied a 0, 0, 0 input to this circuit, in a good condition, what should be your output? If there is no any fault in the circuitry, what should be your output? Yes? Just look at the circuitry. It is a very simple circuitry which is having an AND gate and OR gate. Okay. Now we have applied the input. W1 is equal to 0, W2 is equal to 0, and W3 is equal to 0. Now there is no any fault. Okay, circuit is in a very good condition, and it is giving the result as per our design. Okay, so now what will be output S? Hello friends, am I audible?
मॅम थोडा ब्रेक होतोय आवाज.
Okay. Now is it clear? Okay. I'll repeat my question once again. Okay. This is the circuit which is having one AND gate and one OR gate. Okay. Input to AND gate is a W2 and W3. Okay. And input to OR gate, that is a W1, and output of this AND gate. Okay. And then output S, that is the output of this OR gate. Okay. Now we have applied inputs W1, W2 and W3, that is all are at a 0 logic level. Okay. In a good condition, what will be output of this circuit?
मॅम म्हणजे सगळे तिन्ही W1, W2, W3 1, 1, 1 असतील तर का?
0, 0, 0. Suppose we apply 0, 0, output will be 0. Yes, because as we have applied W2 is equal to 0, W3 is equal to 0, that means output of AND gate will be 0. W1 is 0, that means output of this OR gate is 0, so which will result in a 0 output. But now suppose that A is stuck at 1. Now what will happen?
Output is
this wire is stuck at 1 logic level. What will be output?
Output is 1.
Output will be 1. Yes, it will be 1 because this wire is permanently connected to high logic level. So whatever may be the input that we are applying here, it will result in a high logic level only. That means we are going to get a wrong result. Okay. Then if suppose this wire is stuck at 1, that is the D wire is stuck at 1. We have applied input
D
0,
का
0,
मैम
0 only. आपलं इनपुट आहे 0, 0, 0च आहे, पण डी वायर जर स्टक ॲट 1 असेल तर मला आउटपुट परत काय मिळणार आहे? 1च मिळेल. ओके. Now, if this wire is stuck at 1, then also I will get a result or the output that is 1, which is the wrong result. That means in these three cases, I am going to get output that is wrong. Okay. So that means this vector, that is 0, 0, 0, or this test vector, that could be used to test for these three conditions. That is, these are the three faults: A at stuck at 1, D stuck at 1, and F stuck at 1. Okay. So that could be detected. Now here we cannot analyze whether A is stuck at 0 or not, because as A is stuck at 0, as we have applied the input that is 0, 0, 0, it is going to result in a 0 only. So that means this cannot be analyzed, or other conditions cannot be analyzed, but these three conditions can be analyzed with this vector. Now suppose we apply a vector that is 0, 0, 1. म्हणजे मध्ये W1 0 आहे, W2 0 आहे, and W3 1 आहे. Now at this condition, for good condition, output will be equal to what will be good condition output? W1 is 0, W2 is 0, and W1 is 1. That means output of this AND gate, that will
zero.
be 0. Yes. And as W1 is 0, so result will be equal to, output will be equal to 0. Okay. Now suppose A is stuck at 0. It will not affect on the output. It will show the same result only. But now, if suppose A is stuck at 1, what will happen? It will produce a wrong result. Am I correct? Now, if B is stuck at 1, what will happen? Again, output of this AND gate will result in a 1, and therefore output of this complete circuitry, that will result in 1. That means it will produce a wrong result at B stuck at 1. Okay. Similarly, it will result wrongly when D stuck at 1 and F stuck at 1. That means for this vector, we will get 4 faults detected. Okay. So these 4 faults can be detected with this one vector. Again, if we apply 0, 1, 0, then we can get these 4 faults detected. That is the A stuck at 1, then C stuck at 1, D stuck at 1, and F stuck at 1. Okay. Now suppose we apply 0, 1, 1 to this circuit. Okay. So W1 is 0, W2 is 1, W3 is 1. Okay. Now what will happen?
F is equal to 1.
F is equal to 1 in a good condition. But if here A is stuck at 0, what will happen? It will not affect on the output, because already it is equal to 1 because of this input. So it will remain as a 1 only. If A is stuck at 1, then also it will not affect on the circuit performance. It is going to result as a 1 only. But now, suppose B is stuck at 0, then what will happen? Output of this AND gate, that will result in a 0, and therefore F will be equal to 0, is wrong result, and therefore that means this fault can be detected, that is a B stuck at 0, when we are applying input that is 0, 1, 1. Okay. Also, if C is stuck at 0, that could be also found out, because here when C stuck at 0, again output of this AND gate, that will become 0, and therefore F will become 0. Similarly, D stuck at 0 and F stuck out 0. These faults can be found out with this input. Now, similarly, if we apply 111 as an input to this circuit, what will happen?
मॅडम स्क्रीन दिसत
मॅम
नाही.
स्क्रीन नाही.
स्क्रीन दिसत नाहीये?
हो मॅम स्क्रीन दिसत नाहीये.
Wait a minute. Okay. Now is it visible?
येस मॅडम.
Am I audible properly?
येस मॅम.
So now, suppose we apply an input vector that is 1, 1, 1. Okay, that means again we are applying W1 is equal to 1, W2 is equal to 1, and W3 is equal to 1. In a good condition, what will be my output? It will be equal to 1. But now, if this f is stuck at 0, then what will happen? It will result wrongly as a f is equal to 0. That means this f wire, if it is connected permanently to 0 logic level, I may get a wrong result. I will get a wrong result. But if suppose any another condition occurs, it will not affect, but only for this f at 0, it will result wrongly. If a is 0, but because of B and C, we are going to get a 1 result. If A is stuck at 1, then it will not affect on the output. If B is stuck at 0, then as A is equal to 1, output will be 1. If C is stuck out at 0, as A is equal to 1, so we will get a 1 result only. So that means only for F is stuck at 0, we will get a fault that is detected. We get wrong result, and then we can decide that if there is a fault in that circuitry. Okay, so that means if we are applying these different inputs, then we can find out whether there is a fault in the circuitry and not. But now here there are 3 input terminals. That means there will be 8 combinations of the inputs. Okay, but you may think that here we require to give all these inputs, and then we will decide that whether the circuit is faulty or not. It is not like that it is. Now, if you look at these conditions, that is a 0, 0, 1, then 0, 1, 0, 0, 1, 1, and 1, 0, 0. From this, you will find out that all the conditions that are detected. Okay, that means if we give only these 4 input vectors, then also we can find out whether the circuit is faulty for the all conditions or not. Okay, so that means there is no need to give 2 raised to n number of input vectors to detect the faults in the circuitry, but by selecting proper inputs, we can decide the whether there is a stuck at fault or not. Okay, so this is the one example that we discussed. Okay, so right in the similar way, we can find out whether there is a fault in the circuitry or not using this stuck model. Okay. So here the problem with this approach is that when we are going to find out fault using stuck model, if there are too many number of wires that are present, then obviously it will have too many number of faults, because there are too many wires are present, and because of that it is not feasible check fault using stuck at model fault detection method. Okay, because that is not the practical point of view. It will result in a very long process, and that may result in a number of vectors, input vectors that you need to apply, and that because of that, it is not a feasible method that to be used for the testing if there are many number of wires are present. Okay, if there are small less number of wires that are present, then we can go for that method. So there is a alternative method that was required, and the better alternative for this is to deal with several wires that from a path of as an entity that can be tested for several faults using a single test. Okay, so that means we can go with a single path from the input terminal to the output terminal. Okay, and from that we can find out several faults in that circuitry. So it is possible to activate a path so that the changes in the signal that propagates along the path. Okay, so that means suppose we are giving input, we are activating one of the input terminal, and because of that, what will happen? Complete path that will go on changing. Okay, so when the signal propagates along that path, there will be change in the output, and because of that, there will be direct impact on the output signal. So that method is called as a path sensitizing. Okay, so here we have one example. Okay, so you can see here there is a one circuit that is a having two inputs, that is, first of all, there is a one AND gate which has two inputs, that is a W1 and W2. Then output of that AND gate that is connected to NOR gate. Okay, and another input to that NOR gate is a W3. Then output of NOR gate is connected to AND gate, and another input of that AND gate is connected to W4. Okay, and then we get output of that AND gate, that is the OR gate. Okay, so now what is done in this path sensitizing? A single input is activated, and then from that, how the signal passes through that path, okay, towards the output, that is seen, and depending on that, what is the impact of that input on the output, that is found out, and from that we get the fault that is detected. Okay, so for that, one thing is done is that other inputs that are kept in such a way that will not affect output of that gate. Okay, that means if we have this AND gate, then we are going to sensitize this circuit with the W1 input. Okay, so W2 is kept at one logic level so that it will not affect on the output. Okay, there will be effect of only changes in the input terminal W1. Are you getting this point? Okay, similarly for NOR gate, okay, W3 is kept at a zero logic level, so it will not affect the output of this NOR gate. Okay, only because of this change in this B wire logic level, there will be change in the output. Okay, again for AND gate, again the input terminal B or W4, that is kept at one logic level, so that output of this AND gate will not change because of this, but only it will change because of this C wire logic level. Okay, so now suppose we have W1 is equal to 0. What will be output in a good condition? If there is no any fault in the circuitry, so if W2 is equal to 1, W3 is equal to 0, W4 is equal to 1, and we have kept W1 is equal to 0. So without fault, what will be F?
मॅम W1 काय घ्यायचं मग?
W1 equal to 0. The first case, what we are doing? We are keeping W1 is equal to 0.
1. F is equal to 1.
F will be equal to 1. Or we are applying 1 0 at this input terminal. So output of this AND gate will be 0. As NOR gate, another input is 0. Both the inputs are at 0 logic level. That means output of this NOR gate will be equal to 1. Both the inputs of AND gate are at 1 logic level. That means F will be equal to 1. So here you can find that if W1 is equal to 0, then output will be F is equal to 1. Now if W1, we made it to 1. Now we change logic level at W1. Now what will happen? In a good condition, F will be equal to what will be W1? Sorry, yes. If W1 is equal to 1.
Zero. F is equal to 0.
F is equal to 0. कारण आता इथे काय असणार आहे W1 1 केलं 1 1 output will be 1 for this AND gate. This is 1, this is 0. Output of NOR gate will be 0. And as one of the input terminal of AND gate is a 0, that means output will be 0. So that means F is equal to 1 when W1 is equal to 0 and F is equal to 0 when W1 is equal to 0, 1. Okay, so this is a good condition output for this value logic level which are present at W1. Okay, now at that time what we have done, we have made kept this input terminals W2, W3 and W4 in such a way that it will not activate this output of each of these. Okay, so that means what we have done actually, we can say that we have activated path from W1 to F. Okay, but in a more technical term, we say it as a we have sensitized path from W1 to W. Okay, so that means here as the output changes because of this W1 only, so we say it as a path is sensitized from W1 to WS. Okay, and that is called as a path sensitization. Okay, now suppose we will take one example. We have W1 is equal to 1. Okay, now A is stuck at 0. Okay, are you getting my question? W1 is equal to 1, but A is stuck at 0. What will be your output? Actually,
Ma'am, repeat कर.
W1 is equal to 1. Okay, in a good condition, F is equal to 0. Okay, we have W1 is equal to 1. A is stuck at 0. Okay, that means this wire A is permanently connected to 0 logic level. What will be the effect on the
Ma'am, 1.
output will become as 1. That means we will get wrong result at the output. Okay, so from that we can decide that this is a faulty circuit. Okay, similarly, if B stuck at 0, if B is stuck at 0, it will produce a output of this NOR gate as a 1, and therefore we will get F that is equal to 1. Okay, again that is a wrong result. Now suppose C is stuck at 1. Okay, म्हणजे इथपर्यंत सर्किट बरोबर आहे, पण माझं C ची जी वायर आहे ती स्टक ॲट 1 आहे, तरी पण काय होणार आहे, मला रॉंग रिझल्ट मिळणार आहे. ओके, सो दॅट मीन्स इफ आय सेन्सिटाइज दिस वायर W1, I can find out these 3 faults, that is A stuck at 0, B stuck at 0 and C 1. Okay, so that result would be, or that fault would be found out using this path sensitization by this W1. Okay, so here in this way we can find out the different faults using different path sensitization. Okay, so this is the one method that is used for the testing of combinational circuit and which is named as a path sensitization. Okay, that means here a path is activated from the input terminal to the output terminal. Okay, all of you got this method? लक्षात आलंय का सगळ्यांच्या, काय केलं ते, काय करतोय याच्यामध्ये, या टेस्ट मेथड मध्ये? Okay, so let us move forward. Okay, so the same example that is explained here. Okay, so here suppose we want to sensitize AND gate or NAND gate. That time what we have to do, we have to keep other inputs as a equal to 1. Okay, that means all other inputs that must be set at a high logic level. And if we are sensitizing path through input of OR gate or NOR gate, in that case we have to keep all the inputs that must be at the 0 logic level. Okay, so that you have to remember whenever you want to activate path from any of the input terminals. So other inputs for AND and NAND you have to keep at 1 logic level, and for OR and NOR you have to keep it at a 0 logic level. This was the one method for the that path sensitizing, that is the one method for testing of combinational logic circuit. Okay, there is a one more method for testing of this combinational logic circuit, and that is a random test. Okay, so in this method we are choosing the tests that are at a random level. Okay, so actually what happens whenever we are generating a test set? Okay, so in a path sensitization as well as sensitizing of for the stuck at model fault, we have to become more rigorous while choosing that test set. Okay, and it is very difficult to generate a test set when circuit is larger. Okay. And because of that, there is a one more alternative, that is to choose the test at random. Okay. Now here we have taken one example, has two input variables. Okay, so W1 and W2, these are the two input variables, and then we have this all the functions for two variables. That means actually suppose we have only one. Okay, how many logic levels will be there for one input, or how many combinations for input will be there for one input variable? माझ्या सर्किटला जर फक्त एकच इनपुट असेल, ओके, what are the possibilities of the output? How many combinations that I can have for the input, and then इनपुट पॉसिबिलिटी काय आहेत? एक तर 0 असेल किंवा 1 असेल. ओके, सो दॅट मीन्स देयर विल बी 2 raised to n number of possible combinations for the input. Okay, now again I am saying that my output is 0, but at the same input is 0, but at the same time, because of the fault, it may happen that it may be either 0 or 1. Okay, so because of stuck at fault or whatever is the reason, it may happen that the output may be either zero, sorry, input may be either 0 or 1. Okay, similarly, even though I am saying that input is 1, but it may be either 0 or 1. Okay, so that means total 4 input combinations, that or 4 functions may be there for only one variable. Okay, so that means, in other words, we can say that if we have n number of input variables, then we get total functions, that is 2 raised to n number of functions for that uh, circuit. Okay, so that means now if we have 2 input variables, there will be 2 raised to 2, that means 16 variable functions for that circuitry. Okay, so here, okay, uh, we have this F0 to F15 functions for the input variables, that is 0, that is of a 2-bit, that is a W1 and W2. So suppose we have the input that is a 0 0, then possibility is that correct condition is present. That means if I am saying W1 is 0, it is actually 0 present, and W2 is 0, so that means it is actually 0. So that means for F0 it is a 0 only. Okay, but if suppose W1 is 0, W2 is 0, that is the actual condition, but W1 is 0 and W2 is 1. Okay, so in that case, this is the another function, that is the F1, and similarly it will be for all the functions. Okay, so here this is the table for the 2 variable function. 2 variables, how they will have the different functions. Okay, now let us take one example for how we are going to test. Actually, we are going to use this table. Okay, so now we have the circuit. Okay, this is actually a XOR gate circuitry which is implemented using NAND gate. Okay, it has 2 inputs, that is W1 and W2. Okay, now when input is a 0 0, what will be output in a good condition?
One.
See, input is 0 0. It is a XOR gate, I have told. Okay, you can keep using NAND gate. This is 0, this is 0. So output of this NAND gate will be,
Ma'am, it is a NAND gate, so the 0 0 is 1.
this is 1. Okay, what is output of this gate? That was my question. Now here it is a 0, it is a 1. Okay, so 0 1, that will make this circuit output as a H cancel mode.
0.
H will be equal to
H is equal
0.
to 0 and K is equal to 0.
Okay, so F will be equal to,
And F is equal to 1.
H will be equal to what you said? H and K?
Ma'am, D is equal to 1 if W1 and
D is
W2
equal to 1, yes.
is 1.
K is
And 1
equal to 1.
H is equal to 0 and K is equal to 0.
Just look at the circuitry again. That's why I am asking what you said. See, W1 is equal to 0. It is applied at one of the terminal of NAND gate. Here it is 1. 0 1 is the input to NAND gate. So what will be output? H will be equal to,
Ma'am, W1 and W2 are equal to 1, na?
0 I said. 0 0.
Sorry ma'am, 0 0.
0 0 आहे तर याचा आउटपुट 1 येणार आहे ना मग.
F is equal to 0.
Yes, F will be equal to 0. Just see. As W1 is equal to 0, W2 is equal to 0, D will be equal to 1 because it is NAND gate. So if any one of the input terminal of NAND gate is 0, output will be equal to 1. So here we will get 1. Now W1 is connected to this NAND gate, so it is 0. That means output will be equal to 1. Similarly, K will be equal to 1. Now, as both the input terminal of this NAND gate is at one logic level, that means it will be equal to 0. Okay. Now, if there is a input that is a 0 or 1. Okay. So, W1 is equal to 0, W2 is equal to 1. Now, what will be output? Yes. W1 is 0, W2 is equal to 1. What will be output?
D is equal to 1.
D is equal to 1. H will be equal to?
H is equal to 1 and K is equal to 0.
Yes. So, F will be equal to?
H is equal to 1 and K
0.
is equal to 0. And F is equal to 1.
Yes. H is equal to 1. K is equal to 0. And F is equal to 1. Okay. So, this will be the output. That means whenever W1 and W2 both are in condition that is a 0 1, we will get F is equal to 1. Now, let us assume that D is stuck at 0. Okay. So, this wire B is stuck at 0. W1 is equal to 0, W2 is equal to 1. In this condition, what will be effect on the output? Whether there will be effect? First tell me whether there will be effect and then?
No, ma'am.
Now B is stuck at 1. Okay. W1 is equal to 0. W2 is equal to 1. And B is stuck at 1.
D is equal to 0. H is equal to 1. K K is equal to 1.
Hmm? So output will result in a 0. Okay. Actually, in a good condition, what was the result? Output, it is equal to f is equal to 1. But now it will result as a f is equal to 0. So with this here, with this input condition, we can test for the output result, and then from that we can decide whether the circuit is faulty or not. Okay. So similarly, we can go with the different combinations, and then we can check for whether there is a fault or not. Okay, so here there is a effect of various faults that is specified. Okay, so if B is stuck at 0, what will happen? Then B is stuck at 1. So which type of which function that is going to be activated, so that we have recorded in this table. Okay, so this is the random test for the testing of logical circuit. Okay, so here we can conclude from this that in a random testing is effective, and after a certain test, the existence of a fault is likely to be detected even in a very large circuit. That means we have considered here a very small circuit, but if we have more number of input terminals, that means if there are more number of wires present in the circuitry, then with a more test we can find out whether there is a fault or not in the circuit. So random testing works particularly well for circuits that do not have high fan-in. Okay, if there is a high fan-in present, then it may be necessary to resort to another testing scheme. Okay, so that we need to consider. Now, as this random testing, that is a very simple, so it is the attractive feature of this random test. With connection or with some more good effectiveness of this test, this technique can be is mostly used in a practice. Okay, so this is the one method that is used for testing of digital circuits. Okay, so these are the different testing methods for combinational logic circuits. Okay, now so we have discussed till now the three methods, that is a Stuckert model, then path sensitization and random test. Okay. Now these methods that are used for the combinational logic circuits. But as I have earlier said that in a sequential logic circuits, these methods are not sufficient because in a sequential logic circuits we have to consider a previous state output also, and that is why these methods will not work on the sequential logic circuit. So there we need to have certain different methods, and we are going to discuss about these different methods in the next lecture. Okay, so for today we will stop here. If you have any doubt, you can ask. Do you have any doubt? Okay, I think then you don't have any doubt. So let us stop for today. Uh, we will meet in the next session then. Okay, so till then, bye.